All right. Okay, we're good. All right, so first one. Suppose pair computing sold an average of mean 45 whatever per minute 2011. Yes, that means they sold that much. Okay, standard deviation is 10. They looked at the PFON sales data and determined that they are normally distributed. Okay, so our mean is 45 and standard deviation is what?
10.
Good. Okay, so this one, it's asking, so number 4, it's asking for the shape. Because that sample size is so small, I'd say it's right skewed.
It's actually normal because it says that it's normally distributed in the problem.
Oh, it does. Okay. It's the one thing I didn't open was the answers. Okay. All right. Sample size N is 440 and are taken from normally distributed. So this one will be normal as well.
Right.
Yeah. Okay. Sample size 4 is taken from a normally distributed. What is the probability that the observed is less than 40? All right, so now we need to use the probability app after we find the z-score. Right?
Right.
Yeah, if anything that messed me up, and I asked the question before he recorded it, was I was not happy with them using different decimals. You get a different answer.
Right.
And I can't do math this morning.
Okay.
Square root of 4 is 2 divided by 10, that's 5. And
Yeah, you get
40 minus
-1.
45. So it's 1, or negative
Right.
1.
Right.
Oh. Huh. Okay, so less than. So it's a 15 or 0.1587.
Correct.
Yeah, that's what I got. All right. Sorry. Like I said, I'm. Okay. Sample size N is taken from a normally distributed sale. What is the possibility that the observed X is greater than? Okay, so now we need to find the two different ones, don't we?
Right.
Don't we have to find the two different Z's and then subtract them from each other?
You do, yeah.
Okay. All right.
So if you want to take one and then I'll take the other.
Yeah, so the bottom half will continue to be 5 because because the sample size is the same. So square root of 4 is 2, and the standard deviation is 10. So 10 divided by 2 is 5. So first one is, what is it?
For the 35 or the 55?
For both.
Well, no, because it's 35 minus 45, so you get a -2 is your z-score.
No, that's not what I meant. That's not what I meant for the C. I meant for the bottom part of
Is 5, right?
the standard deviation, or the standard deviation divided by the sample, square root of the sample.
Is 5.
Yes. So yeah. Who keeps calling me? All right. 35 says it.
It's negative 2 on the 35,
Oh, gosh,
and then
yeah.
2 on the other one.
Okay, so hold on. Hello? Okay, I'll have to bring them after I'm done with class, hon. All right, bye. Yep. All right, love you, bye. Sorry, my daughter forgot her shoes for gym.
That's the best.
Oh, I know. I know, got another class, and she has gym early. All right, so one was -2 and the other one was 2.
Right.
So we're just looking between the two of them, aren't we?
Mm-hmm.
What the area is between the two of them. So it'd be the 95.
4.
That's not right. I guess it is.
It is, yeah, 95, 4, something or other, but they've got 95.
95-45.
Yeah.
All right. Number 8. Sample size is 25. Taken from a normally distributed. What is the probability that the sample mean is greater than? Okay, so now we've got to find a different one, but the standard deviation is still the same of 10. Okay, so square root of 25 is 5. So now we've got denominators 2. 41 minus 45 is -4, so it'll be -2 for the first one.
Right.
And then are you getting +2 on the other one?
Yes.
Yeah.
So it's the exact same.
So it's the exact same.
95-45.
So 90, yeah. Okay. Simple enough. Okay, sample size of 25 is, okay, greater than 50. So now we just need to find one that's greater than 50. So 5, it's 1. No.
No,
Yeah.
50 minus 45 is 5. Divided by 2 gives you the
2.
2.5.
Okay.
So it's
5.
0.0062.
Yeah. Okay, sorry. 5 divided by 2. So 2.5
Uh-huh.
was the z-score.
Right.
And the shake a little bit back. So 0.0062, is that what you got?
Mm-hmm.
Okay.
Yep.
All right, simple enough. So, all right, pair computing sold. Okay, that's the mean. Standard, okay, this one's skewed to the right.
Mm-hmm.
Okay, standard deviation. Okay, sample size of n are taken from a right skewed. So this one is a right skew, isn't it?
No, because it's a sample size of 40. So the shape is going to be based
10
off.
is 4. 10 is 4, and then
Oh, I'm
11
sorry. I
is
thought you were
40.
talking about 11.
No, yeah, no, 11 is definitely normal.
Right. Yeah, 4 is going to be right skewed.
Okay. Okay, number 12. Is there a theorem that justifies your answer to... So the theorem for 12 is the central limit theorem.
Well, I think he gives it away because it asks if there's a theorem. The other one's called the law of large numbers.
Yeah, law. Yeah.
He gives it away, which is
Yeah,
nice.
so CLT. Although I did like his chart, so hopefully he'll send that this morning.
I haven't looked to see.
Yep.
I probably email him like 4 or 5 times a week with dumb questions.
I don't think there's anything such as the dumb question. Sorry.
Oh, I'm sure he's thinking that. He's like, really?
Well, the more questions you're asking, the more in tune you are. That's kind of where I'm at. That's my head. All right. A sample size of n is taken from right skewed. We want to know the probability that observed sample size of less than 35. All right. So 35 minus 45.
Can't do that. They're asking you, can you compute it using the applet? And you can't because the applet's for normal probability, not right skewed.
Ah. Okay.
Does that make sense?
Then the answer is no.
Yep.
Okay. Not right. Okay. All right. Sample size of 36 is taken from a right skewed. What is the probability that X bar is greater than 36.5? Okay, so we can compute this one. 36.5 minus 45.
Right.
Square root of 36 is 6. Divided by 10.
12.
12. Is it 12?
Yeah, because it's the pair computing that has the deviation of 12, not 10. On that second set.
On the 14?
Yeah.
We change numbers. Blah, blah, blah. All right. So 12.
So it's gonna
divided by 6 is still 2. Right. 2's the bottom.
So you've got negative 3.5 divided by 2 gives you a negative 1.75. So then when you plug that...
Oh, hold on. It would be helpful if I used the right numbers. Give me a minute.
You're good.
I am awake. I really am. I promise. So negative 1.75.
Right.
Right?
Yeah. So when you plug that into the applet, you get the 0.9599.
So 0.9599. Yep.
Right.
Okay. All right. Sample size of 36 is taken from a right skewed. What's the probability observed between 37.5 and 42.5? Okay, so
You got your
bottom number is 2 again. Okay, so 37.5 minus 40
gives you negative 2.5. And the other one just gives you 2.5. So you've got your negative 2.5 and your negative 1.5 and then your 1.25 and then your 1.25. One's negative, one's positive.
Okay, so the other one's positive? Okay, makes sense. That's nice. All right, so we're doing, do we shade just the middle? Or no, wait, between?
Yeah, in between.
Okay, that's what I thought. So 0.7887?
Yeah.
It's funny how all of those worked out to be that way. Okay. I do know what I'm doing.
I've not done the homework yet for this one, so
No, I won't. I won't do it till later.
I typically try to do it all at once because it seems like the sample or the prep work
Yeah,
isn't
I
quite
I
enough
do
to
the
kind of get you there.
homework. I do the homework after we meet. Oh,
Yeah,
it's in front of
I
me.
try to get it all done, but I've had too much else going on. So
Yeah,
are we
I
ready
hear you.
to start
I
that?
haven't even read my Family 160 class right now. Okay, all right. Are we ready to do the
Yep.
quiz, the group quiz?
Yep.
Get it to load.
Okay.
That'd be great. Okay.
I made sure I opened all of those things before.
Well, I tend to, but then if I've got too many things open, my Hangouts is super sketchy.
Okay, true. True. Okay.
Okay.
All right, number 3. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of the z 1.358 and to the left. Okay. That's simple enough.
Of the whole thing or just, in between the two? Is that what it
Yeah,
says?
in between the two. Okay, negative 1.358. Got it?
So I get 0.8255. Do you get the same thing, Kaylee?
You plug it into the applet, right?
Mm-hmm.
Right. 0.8255.
I'm gonna open the applet.
And now everything on me is crashing. Great. Okay, hold on. I think I got it. I'm back. Don't do that. Close that. Close that. And close that. Gosh, I had it for like a minute and then it went away. Okay, so what did you get?
0.8255.
0.82. Come on, Mr. Hadley. Okay. Let me see if I can pull it back up. All right. Tell me the z-score again. Negative 1.358.
I've got to go back to it.
Okay, I got it.
Yes.
Yeah, okay.
1.358.
82.55. All right, so next one. As extreme.
0.8255.
Say that again, Kaylee.
What did you guys get?
0.8255.
Oh, so it should be 0.826. We only need 3 decimals.
Does it? Oh yeah, it does sit around, huh?
Okay, the United States Coast Guard assumes that the mean weight of passengers in commercial boats is 85 pounds. The previous value was lower, was raised after tragic boating accidents. Standard deviation is 27.6.
26.7.
Yeah, sorry.
Like that
It's
wasn't
what I
a.
read, not what I said.
Okay. Okay. Make sure
All
I
right.
say the same thing.
Yes. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme. Okay, so we're finding it between the two.
So we would go 177.6 minus the 185,
Uh-huh.
correct? And standard deviation is 26.7 divided by a square root of 48. Does that sound like the right setup?
Oh, where's the mean weight is 185.
Right.
Sample is 48. And standard deviation, yeah. Okay, so we're trying to find if it's above or below. So not in between. So find the probability that a random sample passengers will have a weight that is an extreme or more extreme, either above or below the mean.
Okay, I guess I'm confused on this one, just the wording, because it's giving us two mean.
One's a sample mean, so that's your
Okay.
X bar.
That's the 177.6?
Uh-huh.
Okay, so that is the X. Okay.
So that's what hit me last night was the wording that he was talking about between the two, your mean and your sample mean. That's the difference between the mu and the X bar. The words. So as an extreme, as an extreme or more extreme means we are not only interested in values that are lower than the ones we observe, but also the values that are far away from the ones that are in the positive direction. Yeah, so they're not looking for the ones that are in between, they're looking for the ones that are on the right and the left.
Okay. So, let me go.
Unless I'm totally off on that. Somebody correct me, please.
I don't know. 26.7 divided by 48 square root equals 3.85.
And how many decimal points are we? We're doing 3 again.
So 3854 then? But this is the issue. When do we round? Do we round at the very end?
I
Or do
try
we?
and stay consistent throughout. Does that make sense? That's what is driving me batty, is there's no consistency. So if they're going to say that the end needs to be 3 numbers, then they need to have 3 numbers all the way through. That's what drives me batty.
Yeah, but is that accurate? You know what I mean? Or how much? I guess maybe let's calculate it out both ways and see if it changes the answer.
Mm-hmm.
Right. So go 4 and then see what it does, maybe.
All right. So I got a negative 1.92.
Yeah, I got the same thing.
Okay.
What about you, Kaylee?
Yeah.
All right. So that's the z-score. 0.920. All right. So now we're looking for the 2. So I have 0.0549.
Okay, so
For
what
the
did you do on the probability applet?
I didn't do the middle and I did the left and the right. Because those are the more extremes.
0.0549.
Mm-hmm. So if they're wanting the 3, then it's 0.055.
Let me read that question again, just because I don't like it.
I know. So find the probability that a random sample of passengers will have a weight that is extreme or more extreme, either above or below the mean that was observed in the sample. So, and it says a note, as extreme or more extreme means that we are not usually interested in values that are lower than the ones we observe, but also the values that are as far away from the mean as ours in the positive direction.
Okay, that's a nasty question.
Yep.
I don't like it.
Don't do that.
So 0.055, you guys think?
Yeah.
Okay.
Okay,
Yeah, 0.055.
right. Okay, so which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? Ugh. This one I gotta think about.
Okay, for it to be smaller, we have to have a large, is it larger population or smaller? Larger. The larger the population, the smaller the deviation, right?
Yeah, the closer the mean gets to the
Yes.
regular mean, yeah. Okay, so which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations.
It's the sample mean, it's the X bar. Right?
Yeah, that's what I think.
But when they're talking about the distribution of the means, they're talking about what it looks like, right?
Yeah.
So they're talking about the look of it, but they're not giving you any, do you know what I mean?
But they're not talking about the. Oh, you go rumba. Seriously.
If 9 observations are drawn randomly, which of the following will have a smaller standard deviation? How will you know which will have a smaller standard deviation if you don't have any information?
Well, that's kind of where I'm going. Is this that can't be determined from the information given because we haven't been given the mean.
Right. The distribution of the sample means the distribution.
We don't know how big the parent population is.
Right. What do you think, Kaylee?
I think it's, I don't know.
Because we're given the standard deviation, but deviation from what?
I think it can be, I think it's either the first or the second. I don't think it's this cannot be determined.
Okay, can you explain why? Because I'm
Um,
totally lost. I'm not, I'm not doubting you. Because I just keep thinking distribution. When they're talking about the distribution, it's the shape, right? Or is that not correct?
Yeah.
Which of the following will have a smaller standard deviation than distribution? Individual observations. Distribution of the sample mean. I don't think you can tell. They haven't told you anything. I mean, how would you know that the distribution of the individual observations would have a smaller standard deviation than the distribution of the sample mean?
Okay, so it goes back to the question from number 13 from our iPrep. It gave us a sample size. It says it's rightly skewed, but it didn't give us a mean. I don't think you can. Well, that's rightly skewed.
Well, that's just talking about can you compute the probability.
I know. Yeah. Distribution of the small sample size. Blah, 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 blah. All right, let's skip it and go on and come back. I'm just.
Okay.
All right, so I think number 6, which of the following results imply that the spread in X bar decreases as the sample size increases? I think that's the law of large numbers, because it's talking about the spread, not the shape.
Right.
Central limit is shape.
Okay, so scores on the quantitative portion of the GRE are approximately normal distributed with a mu of 150.8 and standard deviation of 8.8. Use this information to answer questions 7 through 10. Diane earned a score of 160 on the quantitative portion of the GRE. What was the z-score corresponding to Diane's score?
Okay, Diane, score was. Okay.
So her score minus the mean, right?
Mm-hmm.
And then divided by the standard deviation.
And sample size.
It doesn't give us sample size.
We don't have a sample size, so we're just doing regular z-score.
Okay. See, and I guess that's what confuses me is when you flip from the, when you flip between the two.
Yeah, and that goes back to reading the word. Is it sample mean or is it just mean? X bar or mu?
Did you guys get 1.045?
I haven't gotten that far yet. Sorry, you're way ahead of me. I'm still like making sure I understand.
So it's 10.8 divided by 8.8. What did you get, Kaylee?
1.045.
No.
What'd you get?
Hold on, I'm going to redo it. Because I can't do math today in my head.
I got 1.0454545454545.
Yeah.
I got. So
Okay.
1.045.
Yep. And we do how many places? 3.
So 1.045.
Yep. 1.045. Okay. What is the probability that a randomly selected student with a score above 60 on the quantitative portion of the GRE? Okay. So it's greater than?
So now we plug the 1.045 into the applet and shade right?
Yep.
Should, yeah.
And shave. Yeah, greater than.
.1480.
Yep, that's what I got. So 0.148.
Yep. Yep.
A random sample of 5 students were selected to take the GRE. The scores were 160, 175, 163, 149, 153. What is the z-score corresponding to the sample mean of these students' scores? So
Now
do
we have to determine the mean between those scores.
Of those. Okay.
Yep. So 160 plus 175 plus 163 plus 149 plus 153 divided by
5. So
I got 160.
Okay, that's what I got.
Okay, so that's our mean.
So we need the z-score corresponding with that?
Yeah. And the sample is 5. Well, that's a crummy question.
What is the student? How do you figure that out?
Yeah, because we don't have the standard deviation.
Do we just use the same standard deviation that we had before?
But we're also missing.
Okay, so this one has a sample mean. So that's your X bar. So now we're going, so if we use the information, well, and it says in before 7, it says use the answers to the questions for 7 through 10. So yes, we do.
Oh, okay. Good. Because I'm like, give me anything.
Okay, so what we just calculated for the mean is the sample mean, so the X bar. So we use the old one of 160 minus 150, 150.8 over standard deviation of 8.8 to the square root of 5.
Good grief.
I know. Goes all to the wording.
So we end up with our 9.2, which gets, oh, cancel. Sheesh.
All right, I got a z-score of 2.363. I rounded the 2.
Oh, okay. I got something totally different.
Okay, that's
What'd
fine.
you get?
I don't know. Hold on. Let me make sure I did this right.
Because I got something different than she did too.
Okay, hold on. Let me do this one more time. .2. Oh, 2.414. What did you have, Justine?
Hold on. I had 2.337 or 338. Okay, I don't like that.
Let's do the basic math again. Okay, so we've got 160 minus the 50.8 gives us 9.2, right?
Right.
Okay. And then we take 8.8 divided by 5, push the square root button, equals 3.935479. So then you
Right.
take your 9.2 divided by the 3.935. 9.2 divided by 3.935, and I get 2.33799.
Yep. So
Yeah.
that's, yep. Okay.
So
2.3338.
What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by students in the previous problem?
Blah.
Round
Okay.
your answer to 4 decimal places.
Okay, so we just take the z-score that we just got, put it in there, and then put it in the applet.
And shade right.
Greater than.
Okay.
Can it be that simple?
I don't know. No. 2.338. So I would get
I would say yes because you've got 4
0.0097.
numbers there. And it's asking,
0.0097?
yeah. So, and it's asking for 4 numbers this time.
What do you think, Kaylee?
Yeah, 0.0097.
Or is it a trick?
No.
I think there's a trick.
I don't think so.
Please, now.
Okay. Suppose the mean GPA of BYU Idaho students is 3.5, distribution is left skewed, a random sample of 81. It's approximately normal because it's 81 students.
Samples.
Even
Okay.
though it says it's left skewed, it's approximately normal.
Right. Agreed. Because the sample size is larger than 30.
Yes.
CLT.
What is the mean of the distribution of the sample means? Blah.
X bar. X bar.
Isn't that mu?
That's X bar. Sample mean is X bar. Mean is mu.
But what is the mean? What's the mu? Like I tried it in my head, and I know it's a big jumbled jungle in there, but I try to like, as I'm reading it, figure out what the heck they're asking. So
Well,
what
they're
is
the
the
same
mean?
thing. It doesn't really matter. It's just what do you put in. So, okay, what is the mean of the distribute of the sample size? Sample distributing, which is the X bar, for all possible sample sizes of 81 that could be drawn from the parent population. So it's the same thing. So it's
Like I don't even know. Like seriously, I read that question and I don't even know what they're asking.
it's 3.5.
Okay, where can we start from the beginning there? Sorry.
Yeah. Okay.
I
So
don't even know what they're asking.
okay, so go above 11 and let's write out what each one is. Okay. Your mean is 3.5. Your standard deviation, or sigma, is 0.7.
Okay.
Left skew, and the sample size is n, is 81. Okay. Remember that the mean is the same, unless they give you something else. From the parent population. It's talking about the parent population. It's the same. So
Okay, so
12 is asking, what is the mean of the distribution of the sample means, sample distribution for all possible samples of size 81 that could be drawn from the parent population? The means are the same, remember?
right. So the
So
mean,
it's 3.5.
say 3.5 or 3.8?
It says 3.5 on mine.
Okay, I wrote down 3.8 for some reason. That's why I'm like, I am so confused. Woo.
Like,
3.5. Okay. What is the standard deviation of the sampling distribution of the random X bar with the mean of 81 students who select Ranger answer to the third decimal place? Okay, so this is just,
okay, so your 81 students is your sample size.
yeah, that's your N. But I'm just
Mm-hmm.
looking at this thing as asking for the sampling distribution. So if it's asking for that,
It's asking for the standard deviation of the sampling
of the
distribution,
sampling
right?
Mm-hmm.
so do we have enough?
What is the standard deviation?
The deviation is 0.7.
It's not always the same though. Don't we have to change something on that one? Aye.
Available.
Let's go. No.
What is the standard? I look at this and I think, oh, this should be
Okay,
easy.
okay. So we need to calculate the standard deviation with using the information that we have from the parent population.
But
Okay?
do we have enough information?
Yes, because we use that's just the simple sigma divided by the sample squared. It goes less than 6.
So the 7 divided by 81 squared?
Yeah, which should be 9. Square root of 81 should be 9.
Yeah. So 0.7 divided by 9?
Yeah, 0.7 divided by 9. So your standard deviation would be 0.07. How many decimals do they want? 3?
So 0.78?
3.
Yep.
7, 8.
Okay. What is the probability that the mean GPA for 81 randomly selected students will be less than 3.3?
Okay.
Okay.
All right. So
So
now we have
3.3 minus 3.5 divided by 7 square root of 81, right?
well now
Yeah.
we've got to over what did you guys use for the denominator? The point oh seven eight? Yes.
Probably just the 0.7 from.
Yeah, the point oh seven eight. Because the point seven
That
the
they gave.
point 7 is from the parent population. So they're wanting the mean. Yeah, okay. Ay, caramba. I know what I'm doing. I really do.
Well, I hope you do because I'm totally lost. I have no idea what you guys are talking about.
So now you're using the new z-score. So the z-score from the lesson we just did, calculating the z-score.
We didn't get a z-score, we got a standard deviation.
In 13, we did standard deviation. 14,
Right.
we're looking for the z-score. We've got to look for the z-score and find out what's less than 3.3.
Okay, because you said you've got to use the z-score from the previous lesson.
13, that's how we calculate the z-score from to get the z or the standard deviation from the parent population. So, or the mean, or the sample mean. That's what I mean.
Do 3.5 minus 3.3, right?
Yep.
Yeah. Negative 0.2.
Divided by 0.078.
Yep.
Mm-hmm. So it's negative 2.564.
Yep. And now we got to put that into the applet.
And then we do greater than, but then the next problem is the exact same, or we do less than, and then the next problem is the exact same, and it's greater than. So.
Less than 3.3. Okay.
It's a little itty bitty piece.
Negative 2.564.
So 0.0052. That what we got?
Yep.
Yeah.
But how many to 3 places?
3 places. Okay, so
0.05.
0.05. Yep. And then you said 15 was greater than that number?
Yeah.
Right. And then we just take that one out and shade everything else.
99.48, so 99.5.
Yep.
Or 0.995.
Or do we just shade the right part, or do we shade the middle too?
It would be everything greater than that, right?
Okay.
Yeah, greater than that.
So 0.995.
Yep.
Right. Now we got to go back to that stupid question.
Oh yeah, we do have that one.
Number 5.
I'm going to go with B, the distribution of the sample means.
Yeah, I think that's what I'm going to put.
Because of the central limit theorem. Right?
We'll have a smaller standard deviation.
Sample size is large. Or maybe it's the law of large. No, that's not large numbers either. But it was just something that he said last night, where he was talking about when if it was like 1 or something he said last night, when he showed that from the parent population when you made the mean. So the smaller the deviation, the larger the mean. Or was it the other way around? I think it was the other way around.
My issue is they don't tell us anything besides that there's 9 observations.
Yeah.
Do you know what I mean?
Yep.
And 4. Discrete random standard deviation. I'm trying to find something that talks about what do you need to even figure out. Following have a smaller standard deviation. Lesson 3.
Okay, I think the bottom one is out because I'm going back over my notes and I wrote the key concepts down. And it talks about it can't be computed if we don't know if it's normally distributed. So it doesn't talk anything about that. So we can't. So I think we rule out the bottom one.
That it can't be determined?
Yeah. So it's not C. Not the last one.
Numbers are close. See, this is my only hiccup, is I wrote in one of my notes for, I don't know, somewhere, I just wrote standard deviation equals the measure of the spread. If the deviation is small, the numbers are close. If the deviation is large, the numbers are spread out. This doesn't tell me anything about the spread.
Which of the following will have a smaller standard deviation if 9 observations? It's got to be B.
I'm gonna put B.
Yeah, I'm going on a gut there, Sherry.
I just feel like there's nothing, like they tell me nothing.
Well, I remember him talking about, and here, I'm going to flip over to the camera. So I remember him having the parent population like this, and then he had this the mean that was like this, and he talked about on the bottom where it had this deviation was smaller, and then the mean one would be even smaller. And that's where I'm like, the bigger the parent population or the smaller it is, the smaller the deviation for the other one.
But this doesn't tell me what the parent population is.
No, it doesn't. So, but I'm pretty sure that it's B. I'm gonna go on. Yeah, I'm just something in me is telling me to go with B.
Okay, you go with the spirit there, sister.
Yeah, that's kind of where I'm at. So, are we good on that?
Yeah, I think so.
I'm gonna look it up a little bit more. I doubt that I've got anything here that's gonna say anything different. But
Well, do you want me to hit submit and then I'll be the guinea pig?
you go for it.
Cassie had to work. She just texted me back.
Oh, shoot. Deviation, minimum.
Well, we didn't get the third one right, and it is B.
It is B.
The third one was the only one that wasn't right.
I don't know. And the combined area. What? How do you get that one wrong? They gave you the z-score.
Hold on. They didn't want the middle.
Use the normal probability
To the right of the positive and to the left of the negative. They wanted the outside, not the middle. We did the middle.
Use the normal probability output to find the combined area. Right and to the left.
So Sherry, the third one is 0.175. If you want to fix that,
Point.
because it said to the right of the positive 1.358 z-score, and to the left of the negative 1.358.
See, and I get it. The probability up there is 1.661.
Did I put in the right numbers? I did.
1.358.
Yeah, so you're not shading the middle. You're shading to the left and the right of the z-scores. 0.31358.
0.1661.
1.358.
The cat go away. I don't know. I quit.
Did you get the 0.175 now?
No, I got 0.1661.
What
When
you
I
have?
put
What
it
do
in,
you've got 1.358 as your z-score?
1. Oh, no, I don't. I got 85. 1.358. 1.745. Okay, that makes way more sense.
Yeah, so just put 0.175. I'll never make that mistake again.
I will, because I will continually read the problem wrong.
Hey, I was being sarcastic.
I got number 8 wrong.
What? It's 0.148.
And I got 1.48. I put in the decimal wrong.
Well, you should still have a 94.
I don't know what it is. Who knows? I'm still retarded.
Karma.
It is total.
Oh my
I
gosh.
don't know what I'm doing. I feel so confused. I had felt stronger, at each individual thing. I got it, but then when I'm trying to combine them together and remember, I'm screwed. I'm old. I think if you're over 40, you shouldn't have to take this class because your brain just
Oh,
doesn't work right.
good to know. So I should get my degree before I turn 40. Sounds good.
Please,
I've got 4
yeah,
years.
because you're screwed if you don't.
Sounds good.
I'll be 43 in just over a week. So now I'm really retarded.
I'm
But
not going there.
plasticity, it's gone. Gone.
Yeah.
It's like
Well,
someone
yeah.
pwned my brain. Nothing
My
sticks.
my psych class, that's how I feel. All right,
Yeah.
ladies, I've got to run. I've got 2 kids that need things at school. Of course.
Okay.
And I haven't
I
even started my day.
will.
So,
I'll
8:30 Tuesday?
Yeah, that
Yeah, and
works.
I'll send the thing for it. So hopefully Cassandra can make it.
Yeah. Well, I feel bad. So, but we've got to figure out what we're going to do for our project. So, we're not
Ugh,
talking about any of
I
that
know.
yet.
Let's Google it. We'll Google and see what we can find out, like project
Yeah.
ideas, maybe.
Because we've got about 3 weeks before we've got to do the project proposal.
Yuck. Okay.
Okay.
Sounds good.
All right,
Thank
ladies.
you.
We'll talk to
Okay,
you next
bye.
week. Bye.